Okay, so this chapter we're looking at factoring, and the definition of factor means to express the number as a product, right, of two or more numbers. So for example, if I ask you to list factors of 10, one, remember you did this in like grade 6? 1 times what is 10? So this is a product, okay, 1 times 10 is 10. Remember this, rainbow? 2 times what is 10? Okay, does 3 go into 10 evenly? No. 4? And we got 5. Okay, so these are the factors of 10. 1, 2, 5, and 10. What are factors of 6, for example? 1, 2, 3, and 6. 1 times 6 is 6. 2 times 3 is 6. There's only 4 factors. What we're trying to do in this example is we need to factor. So what we're trying to find is we want to know what are the factors of, what are the two terms in this expression? What are the two terms? 3x squared is the first term, right? And the second term is negative 6. So what are factors of 3? 1 and 3. That's it. Just 1 and 3. What are factors of 6? 1, we just did this, 2. What is the greatest common factor? So what's the greatest factor that they have in common? 3, okay? So that's the first step. We have to figure out what the greatest common factor is. Well, that's the numerical part. Do they have a variable in common? They both have x in common. Well, factoring is the opposite of expanding. So I know that to factor this, okay, I'm going to write it over here. 3x times something will bring me back to this original question. Okay, what's the opposite of multiplication? So it's 3x times something. Well, what's the opposite of multiplying? Division. So if we take the greatest common factor and we divide each term by the greatest common factor, we can figure out what's missing in our expression. So what's 3x squared divided by 3x? Well, what's 3 divided by 3? 3 divided by 3 is 1, or yeah. What's x to the power of 2 divided by x to the power of 1? X. Whenever you have the same base, we subtract the exponents. 2 take away 1 is 1. So I don't need to put a 1 there. Okay. Then what's negative 6 divided by 3? Negative divided by positive is negative. What's 6 divided by 3? And x divided by x? That cancels out, right? Let's check the original question was. So we're going to check what's 3x times 1x?
3x squared.
Good. What's 3x times negative 2?
6.
Negative
6x.
6x. Is this the same as the original?
Yes.
Okay, so what we've done is we factored it. You're trying to figure out what two things can you multiply together to get back to the original question. We're still factoring by finding the greatest common factor. So in the corner here, I'm going to write the greatest common factor. What number goes into 10 and 25 evenly? What's the greatest common factor? 5. Do they have a variable in common? What can both of these be divided by? The highest degree. A to the power of 2. We can't divide a to the power of 2 divided by a to the power of 3 because then you're going to get a negative exponent. We're only working with positive exponents, okay? So you want to look to see what the lowest degree is. That means everything can be divided by that. Does that make sense? Okay, well, because this is my greatest common factor, that means this can be divided by 5a squared, and this can be divided by 5a squared. So what that means is that 5a squared times something will bring us back to the answer. So whatever your greatest common factor is, because it can be divided by that, it can also be multiplied by that. What's 10 divided by 5? What's a to the power of 3 divided by a to the power of 2? Good. Okay, you have to include the sign. So it's a negative divided by a positive is a negative. 25 divided by 5 is 5. And a squared divided by a squared cancels out. That's it. Words. Factoring is the opposite of expanding, so let's expand. 5 times 2. A to the power of 2 times a to the power of 1 is a to the power of, good. 5 times negative 5. And then a squared times 1 is just a squared. Is it the same as the original? So this is correct. Greatest common factor. The numerical part, these are all divisible by 3. And then you want to look to find the lowest degree, which is x to the power of 2, so that we don't have negative exponents, and then y to the power of 2. Good. Here and here. So all of these can be divided by 3x squared y squared. 3x squared y squared. So our answer, we know that 3x squared y squared times something. How many terms are we going to have inside the bracket? 3. Good. Because we're doing this, oops, and don't forget the negative. Okay, what's 9 divided by 3? 9 divided by 3 is 3. What's x to the power of 4 divided by x to the power of 2? To the power of 2, good. Y to the power of 4 divided by y to the power of 2. Good. Positive divided by positive is positive. What's 12 divided by 3? X to the power of 3 divided by x to the power of 2. Good. Just x. We don't have to put to the power of 1. And then y to the power of 2 divided by y to the power of 2 cancels out. And then negative divided by a positive. Okay. 6 divided by 3. X squared divided by x squared cancels out. Y to the power of 3 divided by y to the power of 2. There you go. That's it.
Made with Doodlecast Pro.